When we look up at the night sky, it may feel like we are seeing the universe as it exists right now, but in reality, every star, every galaxy, and every faint point of light is showing us a moment from the past. This means the deeper we look into space, the further back in time we see. Some galaxies are so far away that their light began its journey billions of years ago, long before Earth even existed. Astronomers use powerful telescopes to capture this ancient light, allowing them to study the universe when it was still young. In a sense, telescopes are not just tools for observing space. They are machines that reveal history written in light. For many years, scientists believed they understood when the first galaxies appeared in that distant past. But new discoveries are beginning to suggest something surprising. In the beginning, the universe was not filled with shining galaxies or brilliant stars. After the Big Bang, space slowly expanded and cooled, leaving behind a vast, dark ocean of hydrogen gas. For millions of years, the cosmos existed in silence and darkness, with no light to illuminate its endless depths. But gravity was always at work. Over time, invisible forces began pulling those clouds of hydrogen together. Slowly, patiently, the first stars ignited. Their light pierced the darkness, and the universe experienced its first sunrise. Astronomers call this moment the cosmic dawn, when the earliest stars and galaxies began to glow across the young universe. Astronomers call this moment the cosmic dawn, when the earliest stars and galaxies began to glow across the young universe. Astronomers call this moment the cosmic dawn, when the earliest stars and galaxies began to glow across the young universe. It was the beginning of everything we see today. Yet one question has challenged scientists for decades. When exactly did this cosmic dawn truly begin, and how far back can we actually see? For decades, astronomers searched for a way to see deeper into the universe than ever before. Telescopes like Hubble had already revealed breathtaking galaxies billions of light-years away, but there was still a limit to how far they could look. The earliest galaxies were simply too faint and too distant. Their ancient light stretched and weakened during its long journey through expanding space. Scientists realized that if they truly wanted to witness the universe's earliest moments, they would need a completely new kind of telescope. One designed not just to see visible light, but to capture the faint infrared glow of the oldest galaxies ever formed. After years of planning, engineering, and international collaboration, that vision became reality. The James Webb Space Telescope was built as humanity's most powerful cosmic observatory, created to peer further back in time than any instrument before it, and with it came the hope of answering one of astronomy's greatest mysteries. Unlike any telescope before it, the James Webb Space Telescope was designed with a single goal in mind: to see the oldest light in the universe. At the heart of Webb is a massive golden mirror made of 18 hexagonal segments, carefully aligned to collect incredibly faint signals arriving from the depths of space. These signals are not the kind of light human eyes can see. Over billions of years, as the universe expanded, ancient starlight stretched into longer wavelengths known as infrared. To capture this hidden glow, Webb carries powerful infrared instruments capable of detecting light that began its journey more than 13 billion years ago. In a sense, the telescope acts like a time machine, revealing chapters of cosmic history that were once completely invisible to us. Scientists believed Webb would finally confirm their models about the universe's earliest galaxies. But when the first images arrived, something unexpected began to appear. When the first deep images from the James Webb Space Telescope began arriving, astronomers expected to see small, faint galaxies slowly forming in the early universe. According to long-standing models, the first galaxies should have been tiny and chaotic, gradually growing over billions of years as gravity pulled matter together. But Webb's observations revealed something completely unexpected. Hidden in the distant darkness were galaxies that appeared far larger, brighter, and more developed than anyone predicted. Some of them seemed to exist only a few 100 million years after the Big Bang. In cosmic terms, that is almost unbelievably early. If these observations were correct, then something about our understanding of how galaxies form might be missing, and it raised an astonishing question. How could such massive galaxies appear so early in the universe's history? As astronomers studied the images more carefully, the mystery only deepened. These distant galaxies did not resemble fragile beginnings. Many appeared surprisingly large, bright, and structured, almost as if they had already lived through billions of years of growth. According to previous models, the early universe should have been filled with small, scattered galaxies still struggling to form their first generations of stars. Yet the Webb telescope was revealing something very different. Some galaxies seemed massive and organized at a time when the universe itself was still extremely young. It felt as if cosmic evolution had moved far faster than anyone expected. For scientists, this created a mixture of excitement and uncertainty. Either galaxies formed much more quickly in the early universe, or the theories used to explain cosmic history might be incomplete. One thing was becoming clear. The universe still held surprises, and Webb had only just begun to uncover them. For many years, astronomers believed they had a clear picture of how galaxies formed. The universe, according to these models, built its structure slowly. Small clouds of gas collapsed under gravity, forming the first stars. Over time, these stars gathered into small galaxies, which then merged and grew larger across billions of years. It was a gradual, patient process that seemed to explain the universe we observe today. But the discoveries from the Webb Telescope are beginning to challenge that comfortable timeline. If massive and organized galaxies already existed when the universe was still extremely young, then something about the story may be missing. Now researchers around the world are searching for new explanations, hoping to understand how the early universe might have developed so quickly. One possibility is that star formation in the young universe happened far more rapidly than previously imagined. Another explanation is that our current methods of measuring galaxy mass, brightness, and distance may still carry uncertainties, leaving room for adjustments as data continues to be analyzed. Medium shot of scientists analyzing complex graphs and holographic galaxy models, highlighting uncertainty. Camera angle, over-the-shoulder view. Lighting, ambient lab light with glowing holograms. Mood, contemplative, analytical. Each new discovery sparks further questions, keeping the mystery alive. Every explanation leads to more possibilities, fueling the excitement of exploration. These findings suggest that the story of the universe's beginnings is far more dynamic, complex, and fascinating than we ever imagined. The James Webb Space Telescope has given humanity a view deeper into the universe than ever before. For the first time, we are witnessing light that began its journey billions of years ago, traveling across time and space to reach us. These images are more than just scientific data. They are glimpses into the earliest moments of cosmic history, showing us how the universe began to take shape. As we study these distant galaxies, a sense of awe spreads. Each new observation reminds us of our small place in the vast cosmos, while simultaneously connecting us to the story of creation itself. The achievement of designing and launching a telescope capable of capturing such faint, ancient light is extraordinary, the culmination of decades of vision, collaboration, and innovation. Each image it captures offers a glimpse into distant galaxies, yet the universe holds far more mysteries than we can yet comprehend. Even as the Webb Telescope continues its mission, we are only seeing the first chapter of its discoveries. Each image it captures offers a glimpse into distant galaxies, yet the universe holds far more mysteries than we can yet comprehend. For decades to come, Webb will reveal details that challenge our understanding of cosmic history, uncovering phenomena that we cannot yet imagine. The excitement lies not only in what has already been observed, but in what is still to come. Every new observation has the potential to reshape our ideas about how the universe began, how galaxies formed, and how the first stars illuminated the cosmic darkness.